Welcome! In this chapter, we're going to explore one of the most common and, frankly, one of the most critical vulnerabilities you'll find in web applications: broken access controls. This is such a fundamental concept in cybersecurity because if an attacker can get around these controls, they can pretty much sidestep every other defense you have and get their hands on powerful admin functions and all sorts of sensitive user data. So to really kick things off, let's just look at this number. A recent study found that a whopping 71% of web applications have some kind of broken access control. And think about what that really means. It means that even if you have a rock-solid login system, your application could be completely wide open if it doesn't correctly enforce what a logged-in user is actually allowed to do. So here's how we're going to tackle this. We're going to put on our attacker hat, starting with the basics, then move into the common entry points and attack methods. After that, we'll flip the script and look at it from the defensive side, learning how to find these flaws and, most importantly, how to build a secure system from the very beginning. Okay, so first things first. What are we actually talking about when we say access controls? At its core, it's really all about making sure that users can only do what they're supposed to be able to do and nothing more. The easiest way to think about this is like a bouncer at a club. Authentication is the part that checks your ID to see who you are. But access control, that's the bouncer checking the list for every single request you make to see if you're allowed in that specific VIP room or allowed to order that specific drink. It's the gatekeeper that enforces all the rules. So when these controls do fail, the attacks usually fall into one of two buckets. First, there's vertical privilege escalation. This is where you're climbing the ladder, so to speak. Imagine a regular employee finding a way into the CEO's office. That's a vertical escalation. Then you have horizontal privilege escalation. This is where you're moving sideways to access data that belongs to someone at your same level. Kind of like reading a coworker's private email. You're not an admin, but you're definitely seeing something you shouldn't be. All right, let's switch gears and put on our hacker hat. The very first step in any attack is always reconnaissance. It's all about finding that one unlocked door that someone accidentally left open. And this right here, this brings us to one of the most common and frankly most dangerous assumptions a developer can make. It's this idea that if a URL isn't linked anywhere for a normal user, then it must be secure. This is called security through obscurity, and it's really not security at all. The truth is, you just can't treat URLs like they're some kind of secret password. Attackers have tons of ways to find them. They can guess common paths like /admin or /dashboard. They can poke around in the client-side JavaScript code. They can even find clues left behind in HTML comments. And since URLs pop up in browser histories and network logs, they're just not a reliable way to protect anything important. Okay, so let's say we've found one of those hidden URLs that looks like it might lead to an admin function. Now what? Well, this is where we start looking at how flawed logic inside the application can be exploited to walk right through that door. You've probably seen URLs that look a lot like this, right? The application is accessing some kind of resource, in this case, a document, using an ID number right there in the URL. Now, the app is probably designed to only show you links to documents you actually own. But the real question is, what happens if someone just types a URL like this directly into their browser? Now, if you're thinking like an attacker, your spidey senses should be tingling right now. The immediate question becomes, what happens if I just change that number? What if I tried 1281-49121, or maybe the one before it? If the application only checks that you're logged in, but completely forgets to check if you own that specific document, well, then you've just found a huge vulnerability. And this is what can happen. This slide shows the catastrophic result of that exact vulnerability. If the app doesn't check for ownership, an attacker can write a simple script that just loops through every possible ID number. And as you can see here, they're harvesting sensitive data, maybe even user credentials one by one. It's such a simple trick, but it can lead to a complete compromise of the entire system. Okay, here's another more subtle kind of flaw that attackers just love to find. It's in multi-step processes. Think about a bank transfer. On step 1, the app checks if you own the account you're sending money from. Great. But what about step 3, where you actually confirm the transfer? Sometimes the application just assumes you're authorized because, hey, you made it this far, right? An attacker can exploit this by grabbing the request for that final step and replaying it with a different account ID, completely bypassing that first check. All right, we've spent some time in the attacker's mindset. Let's flip the script. How do the good guys, the ethical hackers, find these things before they get exploited? Let's open up the Defender's Toolkit. So the single most effective way to do this, hands down, is to systematically test everything with at least 2 different user accounts that have different permission levels. So first you log in as a high-privileged user, like an admin, and you map out every single function and page they can get to. Then you log back in as a regular, low-privileged user, and you try to directly visit every single one of those powerful URLs you just discovered. Of course, trying to do all this by hand would be, well, pretty tedious. That's where tools like Burp Suite come into play. It can automatically map out everything an admin can see, basically creating a treasure map of all the sensitive parts of the application. You then use that map to guide your testing with the normal user account, checking every endpoint to see if the access controls hold up. And this right here is a perfect picture of that process in action. So look at the image on the left. Our low-privileged user tries to hit the main admin page, and they get blocked with a not authorized message. Perfect, that's what should happen. But then look at the right. That same user tries to go directly to a specific admin function, the list users page, and boom, it works. The app just serves up the page. That's a textbook broken access control vulnerability. And remember those tricky multi-step flaws we talked about? Well, to find those, we can use these same tools to do something pretty clever. We can capture a specific request, like that final confirmation step, while we're logged in as a privileged user. Then, we can try to replay that exact same request while we're in the session of a low-privileged user. This is a great way to see if the application is checking permissions at every single step, or if it's just getting lazy after the first one. Okay, we've seen how to break in. Now for the most important part. How do we build a fortress that keeps people out in the first place? Let's pivot to the defender's mindset. Building a secure system really boils down to a few core principles, and they are non-negotiable. The most important one is default deny, which means access is always forbidden unless it's explicitly allowed. You also want to centralize all your access control logic so it's handled in one single place. And this one is crucial. You must never, ever trust any data sent from the user's browser to make a security decision. All of your authorization choices have to be based on trusted server-side session information. So, what does a solid best practice approach actually look like? Well, it means integrating these ideas right from the start. You document your access rules for every single feature. You force every single request through that central permissions checker. You revalidate permissions at every single step of a complex process. You even protect static files by serving them through a script that can perform these checks first. For any application that's even remotely complex, you absolutely need a defense in-depth strategy. And this visual here, a privilege matrix, is a great way to think about it. It clearly defines what each user role is allowed to do, and at what layer. This way, even if one of your security controls fails, maybe there's a bug in the code, another layer of defense, maybe at the network level, is there to stop an attack in its tracks. All right, that was a lot to cover. Let's take a moment and wrap up with the most important lessons from our dive into access controls. So, when you boil it all down, broken access controls almost always come back to one thing: flawed assumptions. The assumption a user won't find a URL, that they'll follow a certain sequence of steps, or that they won't mess with a parameter. The single biggest takeaway is this: never assume. By systematically testing every single function from the perspective of every user role, and by building a layered deny by default defense, we can turn our applications from fragile houses of cards into secure digital fortresses.